Everyone, I'm Marwan, and today I'll be presenting a paper that is actually written by my student Enrico, which is about the Joule heating of 4D printed one-way and two-way PLA grippers using nichrome sheets. So we are a team from the University of Nottingham, Malaysia. Our Malaysia actually has three campuses. The main campus is in UK, and we have a campus in Malaysia and China. So at the beginning, I would like to discuss a few things related to 4D printing, which are important actually for our work. So before we start talking about the design of the grippers, we need to understand a few things that are important for the design, which is the shape programming using the printing parameters. Our team actually focuses on the shape programming of 4D printed structure in general using the printing parameters. So we generally do not use manual shape programming. So in the past, we managed to use the printing speed, printing temperature, and the ratio of passive to active layers and the layer height and the height of the structure actually to create 178 combinations of actuators. And then after that, we analyzed the deformation angle of all of these actuators, and we managed to create a predictive model and FEA model based on this analysis. So for example, what you see here is an equation that is based on all of these combinations. So this leads us to the fact that if we want to create a structure and we want to bend it in a certain angle, then we can just substitute the printing parameters that we are using into this equation, and we will get roughly a good estimation of the bending angle. Based on this analysis, actually, we managed to extend, or we managed to use this principle to demonstrate these relationships. So, for example, if you see the figures here, we can relate the printing speed to the bending angle, printing temperature to the bending angle, and we can even print one structure using different printing parameters to demonstrate the effect of each printing parameter on each part of the structure. And we also extended this concept by using the variation of the passive to active layers and the layer height as well. So from these relationships, before I proceed, we can see that the printing speed has a positive effect on the bending angle, and the printing temperature has a negative effect on the bending angle. Meanwhile, the passive to active ratio of the active layers, we can see that the maximum deformation or the maximum bending angle can be achieved when we use a 50% passive to active ratio. Meanwhile, we can see that the layer height, the lower the layer height, the higher the bending angle in general. But of course, the relationship is non-linear in this case. But the general concept is that lower layer height will give us higher bending angle. So we took this concept a step further. Since we know how to model, or since we know how to estimate the bending angle, then we can create structures that can bend based on our design or based on the desired bending angle. So for example, here, we extended this concept to create grippers with different fingers, and each finger will bend using a certain bending angle that we desired. Sorry. And also this concept was used to create grippers with different, whereby each finger also has a different bending angle based on the induced strain because of the printing parameters. After that, we also use the concept of the printing patterns to control the bending angle of grippers. So in our previous work, we used the bio-inspired printing patterns to create different grippers with different bending angles. And we use these grippers actually to grip non-uniform objects, such as the plug here or the egg. So sorry, I'm actually a bit unwell. And then we extended this concept of the printing patterns by creating also joints in these grippers to enhance the gripping ability, just like the figure that we see here. And we also control the printing direction to create twisting, whereby we want to grip objects that are cylindrical, for example. And then we extended this concept to create a gripper that looks like this, whereby actually these small actuators here will bend and will cause the whole gripper actually to grip based on the deformation of these grippers. And in the past year, I presented this concept actually in this conference, whereby we actually presented 3 different designs that can also grip objects based on this concept, whereby the gripping performance is controlled using the printing parameters. So actually, what's the research problem here? So there is a lack actually of 4D printed micro grippers design. There are not many available designs. Most of them rely on the concept of hand-like gripper. And also when we rely on using PLA, for example, to print this kind of grippers, then we are limited in terms of the characterization and activation approaches. So here we propose 4 different designs, whereby each one of them is suitable for certain application. And also we will use Joule heating to activate these grippers. And we'll have actually 4 grippers. 2 of them will have one-way and 2 of them will have two-way actuation. So here, the first thing that we achieved here, if you still remember, I mentioned that in the past we use certain combinations of printing parameters to achieve or to model the bending angle of the actuators. Now we extended this concept by using additional printing parameters, just like the ones we see in this table. So as a result here, we have a 720 combination of printing parameters that we can use. As a result here, it means that the level of control over the bending angle of actuators is even higher. So here, actually, we also actually plan to extend these combinations even more. So now let's go to the designs. If we look at the designs here, we can see that the structure here, the gray part is made of PLA, and the red and blue parts are made of also PLA, but with different printing parameters. Or we can say that this is the active part, or this is the actuator that causes the gripper to bend. As a result, here it means that when we activate this actuator, it means that this actuator will bend and will cause the fingers to grip the object. This concept has been also extended to create another design, which is slightly different compared to the first one. And also, we extended it to have 2 additional designs, whereby each one of them actually can open and close. So we have two-way grippers. So here, if we look at this design, the first gripper here will force the first actuator here will force the grippers to close and grip, whereby the second actuator will force the grippers to open. So as a result of this reverse arrangement of the actuators, like you see here, the red part is the active part, whereby the blue part is the passive part. So we notice that these grippers are in reverse arrangements, and that's why they will force the gripper to open and close. A similar concept also has been implemented to develop this gripper. So now we have 4 different designs that we can use to grip and release objects. I would say that design 3 and 4 can be used to grip and release, whereby design 1 and 2 can be used to grip only. So we used, first of all, we conducted the finite element analysis, and we modeled the performance of the grippers. And of course, when it comes to design 1 and 2, they are used to grip only, so they are one way. So we just modeled the closing of the fingers. While when it comes to design 3 and 4, they are used to grip and release, so we model the opening and closing of the grippers. Sorry. So now when it comes to the experimental parts of this work, we can see that here in this case, now you are wondering what is the nichrome parts, because I mentioned that we are using nichrome wires or nichrome sheets. So you can see that here the whole structure is made of PLA, and then we connected the nichrome parts at 2 locations here. So this part here, the one that is suspended here, this is the gripper, and it's also connected to a nichrome part, or nichrome wires, and also the outer frame of the gripper also connected to nichrome wire. So what's the reason behind this? We notice that if we activate the actuator only, then as a result, the bending will be slightly less compared to when we activate the frame also. So our idea is to soften up the frame of the gripper in order for us to allow it to bend even more. So this concept also has been used to deal with this design here, which is the second design that also bends one way. Now we can see that when we activate these grippers, then of course this is the initial position, or this is the initial shape, or the printed shape, and this is the activated shape when it comes to the first design. And this is the same concept that has been used to activate the second gripper. Now, if we go to the sorry, this should be design 3. So this one is design 3. So in the third design here, we can see that we have two pair, or we have a pair of actuators, two actuators, one at the top, one at the bottom. And these are the actuators here. This is the top and bottom. And these will be connected to the nichrome sheets. And as a result, these grippers, or these actuators, will force the gripper to open and close. So this is the printed shape, and we can see that this is the closed gripper, and this is the gripper after it has been activated to open. The same concept has been used in the in design 4. Also, we have two actuators, and we'll activate each one of them. And you can see that this actuator, the top actuator, forces these levers to bend downwards so as a result, it will close. And the second actuator will force the gripper to open up. So this is the printed structure, and this is the closed gripper, and this is the open gripper after we activated using on and off. So now you can see the thermal images or thermal videos of these grippers. So when it comes to design 1 and 2, we can see that this is the activation process of these grippers. So we can see also that the time required for heating up or for actuation is a bit long compared to our previous work. This is the reason because we are using this nichrome sheets, and we notice that if we heat them up quickly, then they might lead to undesired performance. They might melt the PLA at certain parts, and that's why we slowed down the heating process. When it comes to the design 3 and 4, so here we can see that the grippers open and close, or actually close and then open when we activate the actuators, actuator 1 and 2 of each gripper. So as a result, these two designs will be able to grip and release objects. And of course, also here, the performance is even slower compared to the previous designs, because here we are required to close and then open the grippers. So in conclusion, we used 6 printing parameters to create 720 printing combinations. And then we developed 4 grippers. 2 of them actually can grip and release objects. And in the future, we plan to use conductive SMP to print the grippers. We actually started this process already, but we have not completed this work. But for now, we are using the nichrome sheets to deal with these designs. So far, that's it for me. Thank you so much for listening, and I hope that we can contribute in the future. Let me know if you have questions, and also if you want to contact me later, this is my email.